hopefully we will get all this done within the time frame that we have. The objective of this presentation is to talk about how to develop a pavement management program so that you can increase the service life. And then you'll hear Tom state this many times, how do we reduce the total cost of ownership, which is the ultimate objective of developing such a program. Again, my name is Sergio Pages. I've been with StructureTec for about 25 years. I have extensive experience in the industry. Tom, if you want to give us a little background on you.
Yes, I'm the manager of the Pavement Management Division here at StructureTec. And with regard to my background, I've worked with Michigan Department of Transportation and their specification committees for 12 years. I was a liaison officer to the Federal Highway Administration through Senator Carl Levin's program, and it's a pleasure to be here with StructureTec today and you folks.
Thank you. So again, let's focus on the objectives for this hour that we're all going to spend together. First, we're going to talk about evaluating pavement projects and determining when do you replace versus when do you perform repairs. What are some of the proper ways of assessing pavement conditions? And then how do we prioritize? If you have a large portfolio, what are some of the best practices for prioritizing? And we'll introduce you to a condition index, the pavement condition index. And then how to ensure that we receive a cross-section that is the proper design so that you can obtain the maximum or the lowest total cost of ownership in the long run. So as we get started, let's talk a little bit about what some of the key factors when we're talking about paving. One of the first factor is its load. As you know, throughout the last 100+ years, the load that pertains to the pavements have considerably changed. Obviously, at the beginning of the century, the loads were very light, but now the loads are much higher. For example, in the state of Michigan, Tom, why don't you expand on that?
Gross vehicle weight in the state of Michigan, not unlike California, and that's two states in the nation that has such a high GVW allowance. Michigan, you can go over the pavement with 168,000 pounds, comparable out in California. And if you've ever seen CD trailers, they're generally affiliated with asphalt plants in the production. In Michigan, they will stack the axles so that the tire spacing is an inch or two in order to be able to handle that kind of gross weight. Crossing the border into Ohio, Indiana, it's 80,000 pounds.
So load factors are obviously a very important factor when you're dealing with your pavement assets. The other factor is cost, and what we have here is a picture of one of the oldest roads in the country, if not the oldest, concrete paved road. This is in Woodward Avenue in the Detroit metropolitan area. This is from the early century. The cost of this road was about $13,000 on those years' time, but obviously cost is a significant factor in constructing these types of systems.
You would have to add some zeros.
That's right.
Sergio, in order to be able to accomplish that feat in this day and age.
The other factor is field quality control. And Tom, if you want to give us a short story behind this picture.
Actually, it was a hands-on kind of an environment, and what I'd like to convey in terms of the message with regard to this photo is field quality control, making sure that there's boots on the job to watch over what's happening with regard to construction. Just under that automobile that is under the surface of the street, there is a 48-inch piece of reinforced concrete storm drains, main junction pipe. At the time we were doing the reconstruction of Jefferson Avenue in River Rouge, this occurred, and a part of it might have been as a result of the construction traffic that preceded this vehicle, but the failure and the collapse occurred while this car was there. So in the bottom, that 48-inch piece of pipe was picked up to be installed in a previous project completed 4 years earlier. It was the storm drain infrastructure, and as they were booming the pipe into position, it connected with another pipe, broke a big half-moon shape out of the bell section of the pipe. They actually clipped off the reinforcement bar that's in reinforced concrete pipe, set the pipe anyhow. Over time, it cavitated and washed downstream all of the substrate under the compacted gravel, and eventually took the street away. Now, that piece of pipe is about $800, okay? But it created tens of thousands of dollars worth of repair sometime later, basically for lack of field quality control and oversight during the construction. Go ahead, sir.
Thank you, Tom. So as we continue, I just want to make sure everybody, if you have any questions, feel free to type them in. There's a section for questions, and we'll answer them at the end of the webinar. Continuing on, let's talk about other factors. Obviously, many of you facility managers, one of the challenges is being able to put together budgets for parking lots, and that there's a lot of effort in trying to come up with budgets. A lot of times a facility manager will spend a lot of time putting together budgets that are based on contractor bids. In other words, you're trying to get a parking lot repaired or restored or replaced, and in order for you to develop a budget, you typically get quotes from local contractors, and then you take the average of those quotes, and that's what you submit to management. And essentially, there's very little time done for inspection of those parking lots, and therefore, perhaps there's some judgments in terms of what needs to be replaced, retrofit, restore, repair, and then there's very little in terms of specification. We advocate that you inspect the parking lots first, and then let the conditions of those parking lots dictate the recommendations. So, for example, some parking lots will merit being replaced. Some of them could be retrofit or restored, or we can do strategic repairs. And then we also will advocate that you develop quality specifications so that you can get sound quotations that are appropriate for the type of situations or conditions that the parking lots are in. And then at the end, this in the long term will save you a lot of dollars because you're going to get a parking or a parking lot that will have a longer life. And then, of course, it will save you time because you're doing things the right way from the beginning. So continuing on, other factors, many of us are pushed by pricing, and that makes the decision in terms of how we're going to go about a project. Then we look at the warranty, and then the last thing we consider is the quality of the work. So we recommend that you should have quality as your number one objective. In other words, you have a quality parking lot, you'll be able to maintain the objective, which is having a solution that will last you for 10 to up to 20 years. And then price, obviously, we need to have competitive pricing. And then lastly, the warranty should be your last line of defense. Other factors, this is what we call the construction pie. The D stands for design, and we're going to elaborate on this, but when you're doing a parking lot project, you want to have a very strong set of specifications. You also have to have good materials that are well specified, tried and proven. And then in terms of the W stands for workmanship, you want to have good contractors that can perform this type of work. This is a key part of every project, having good design, good materials, and good workmanship. And when you do that, you're able to avoid conflict between all parties, making sure that there's no misunderstanding on the materials, on the design, and the contractors that are going to be performing the work. Honing in on the specifications, we highly recommend that you have a very concise set of specifications. We'll give you some examples later on. But the third bullet is what I want to highlight. For those of you who are in the U.S., we highly recommend that you focus on using the Department of Transportation specifications for your local state. So, for example, if you're in Tennessee, you want to have specific MDOT or Tennessee Department of Transportation specifications. If you're in California, you want to have those, New York, and so on. And the reason for that is because by adhering to DOT standards, you'll be able to attract very sound contractors that are familiar to working with the government, and therefore you're going to have high standards and a high quality group of players coming here. And on that note, we highly recommend that you tap into the local Department of Transportation to get qualified contractors that have a tried and proven record. And despite having a good contractor, we recommend that you monitor their work, that you provide for the project good field quality control, construction review. The key for a good project is to have somebody on site full-time looking at the dimensions of the cross-section that were specified, and then having material testing throughout construction so that the products that are being installed in your facility are exactly what were specified by the engineer. And then, go ahead, Tom.
Yeah, and Sergio, I might add that with regard to the DOT pre-qualification, one it can get into a website, go to the local DOT /pre-qualification. It will bring up all of the contractors that are pre-qualified in mass grading, site work, utilities, asphalt paving, concrete paving, and to the limits that they're qualified from a dollar volume in a given annual fiscal year. So there's a lot of information that can be gleaned from that.
Excellent, Tom. Thank you. So, Tom, on that note, let's switch to the sample case why don't you share a little bit about this story behind this particular site?
This is a fairly large public utility site, and if you can envision I-75 just to the right of the screen about a mile away. The inbound traffic comes into two access points, one just east of the building, one just west of the building. The parking lot on the far right is employees parking and has cross sections that handle light automotive traffic, and the center section is typically for employees with regard to pickup trucks and lightweights. On the left-hand side is a heavy duty where all of the low boys, the equipment, the backhoes, the dozers, and so forth come in. Now, that said, it is convenient for the traffic to turn in the first entry to this building. And I don't know, Sergio, where we can get to the top portion where it's coming in off the...
Oh, no, we can't. We don't have that slide here. Okay. It's only this picture.
In any case, the inbound traffic with all of the heavy lowboy activity, there's a better site, truck drivers would just pull in that drive, and the consequence of heavy-duty traffic exposed to light-duty pavement cross-section, and there's some photos as to consequence and results. Basically a $300,000 job that within 2.5 to 3 years was destroyed by the traffic. Now, number of options to be able to control that, put some signage up that says truck traffic only on the west entrance, and automotive traffic and so forth on the right is that heavy-duty traffic that was abusive to the cross-section.
Excellent, Tom. And here's some images of the deficiencies. This is the side of the heavy automotive. then you can start seeing the deterioration only after 3 years. So as Tom stated, the budget for this project was $300,000. 3 years starts breaking down, so basically you have an annual cost of ownership of almost $100,000 a year, and that's due to the fact that the cross section was not properly thought of in terms of putting a cross section for that pavement that will be able to handle those weight loads. So as an example, we have in our screen a sample of a heavy-duty cross-section that's more designed for a heavier traffic, heavier loads. And then we have an example of a light-duty cross-section. So again, the objective obviously being to reduce the annual cost of ownership and ensure that the full life cycle duration of the parking lot. Not having that as an objective, the facility manager for this site, obviously got a good price, but he could have gotten maybe for a few more dollars a thicker cross section and have something that will last anywhere from 15 to 20 years. So the key is, are we being efficiency or effective? Are you doing things right? In that case, that particular project went right. Everything went well when they finished the parking lot, but they weren't doing the right things because in the long term, after 3 years, they lost, their investment. So moving into the next section, let's talk a little bit about basic types of pavement, Tom. So let's start with the rigid pavements.
Portland cement. Reinforced concrete pavements spread the load substantially further across a given area. It falls into possibly the Cadillac cross-section, if you will. It's relatively pricey, stacked up against HMA. That photo, Sergio, is a typical transit mix plant where Portland cements are manufactured and delivered to the trucks and delivered to the site. Flexible pavements, HMA base courses, intermediate courses, surface courses have a tendency to flex with the weight and load, and each and every axle weight. Our axle carries a given amount of weight and creates certain easels and pressures on the pavement, which cause stress over time, which cause life cycle to be reduced. This is a photo of the typical HMA. Well, this really isn't typical because this plant is located just outside of Indianapolis, Indiana, and the contractor had an incredibly sophisticated lab. They stayed on top of their mix designs extremely well. It was very impressive. And the plant was washed down and cleaned every night. So they were very conscious of dust, debris, and dirt that would affect computer systems, laboratory equipment, and in the manufacturing in terms of the operator's pilot house for the whole plant.
Yeah, and part of why we're showing you the material providers or the products is because when you're working with pavement projects, you want to make sure that, especially for those of us who are in the northern part of the North America, the weather is very key. And this particular plant usually open sometime in March, April timeframe, and they usually shut down in the October, November timeframe. So your projects, have to be done within that timeframe. And therefore, it's very important to know that up front when you're executing work. You don't want to do the project too close to the October, September timeframe because you may start getting into risk with weather. So, Tom, wrapping up the comparison between concrete and HMA. Obviously, concrete is better for loading dock areas, perimeter roads, dumpster areas, but obviously you're going to pay 3 times more than HMA. HMA is good for employee parking, automotive traffic, and then obviously the cost is much less than than concrete.
And the items that drive the separation between the two cross-sections is basically the volume of traffic and the gross vehicle weight of that volume of traffic and how it affects the substrate. So sometimes it's separated sheerly by the E18 cross-sectional study, which will assist you on making the proper choice for the cross-section, and it all boils down, Sergio, to the annual cost of ownership and keeping that as low as possible.
Excellent. So let's talk more about pavement technologies and then methods and needs and procedures, as well as maintenance techniques. So we're going to show you some samples of approaches that you can take when you're executing projects. So this screen that we have here on the far left, you can see a site, the upper left, I'm sorry, you can see a site. It's a fairly large site. The site was broken down into multiple sections for planning purposes, for programming. And, you know, pretty much the entire site required full replacement based on the poor conditions. The picture, unfortunately, doesn't show the level of problems that the site had. However, when the request for funding for this project came up, it was about $1.5 million worth of repairs, actually full replacement that was needed. Unfortunately, and I'm sure many of you have experienced this, management only gave us $150,000. So the question came up, okay, where do we spend that money? You know, I mean, we have the entire lot is in bad shape. Where should we hone in? Only $150,000. So on the lower right shows the specific area that was decided to put that $150,000. So Tom, tell us, why did we pick this among the entire site? What was the rationale behind it?
Well, the upper left photo, and I wish we could zoom in on it because it was alligatored and deflecting. There was real wheel ruts in there. This is a 122-acre site, pretty good-sized public utility, and it's a 5-points corner. In other words, the trucks would come in and dispatch to drop off certain inventory on certain roadway accesses. So 80% of vehicle traffic ran through this 5-points or 5-corner intersection, and the $1,300,000 requirement for pavement replacement had to be reduced, prioritize the areas. There was additional areas where that alligator pavement has actually been blown out by snowplows. It was 6 or 8 inches deep, and it was those kinds of areas that became the priority to how best make use of the limited amount of capital improvements in order to repair the site.
Yeah, so essentially the reason for picking this particular location is because it was the place where many of the roads coincided, and it was the area that had the most turns. So therefore it made sense to put the funding there. But then the next question is, how do we tie in the new area with the old area? And on the next screen, we have a detail that Tom will elaborate in terms of connecting the new pavement with the sections that are old attached to it. So, Tom, can you expand on this detail?
Well, Sergio, it doesn't hold true with just full depth repair, but rather it holds true for full depth repair and new paving. The joint overlap is critical. If a saw cut in a repair is made for the full depth of the replacement of the base course and the surface course, then you have that vertical stacked joint. And that joint has a tendency to open up and allow surface water into the substrate and the aggregates. So with new construction and new paving and repair work as well, there needs to be an offset joint. So your base course comes up to a certain elevation, and then you offset an additional foot, if you will, so that the surface course doesn't allow for the stacking of that vertical joint, and down the road reduces tremendously the ability of stormwater to get to the substrate.
Thank you, Tom. So now let's move into concrete. Can you explain a little bit on this procedure?
Typical concrete crew transit mix truck, and in this case you can, in the upper right-hand corner, see epoxy rebar. Depending upon the temperature and the day, crews can vary, fluctuate substantially, and it's the number of folks that you have that's critical and germane to the amount of cubic yards that are going to be poured that day and the temperature. So quality control is at all levels, and manning and staffing has a certain implication based upon temperature of the day and the sheer volume of material that be placed in a given day.
So Tom, give us some feedback on rebar.
Number of different types and sizes. We've actually a lot of studies on raw rebar, say a number 4 bar. This happens to be an epoxy coated bar, and the studies that have been presented with regard to DOT background and support is tie them off on 12-inch centers and ring tie them in place. Epoxy bar is a little bit more expensive than the raw bar, but substantially less than galvanized and other coated bar. The outcome of using epoxy coated bar is you minimize that slab separation, where raw bar will have a tendency to rust. It will rust on that 12-inch on-center grid, and occasionally sheer weight and volume will cause the slab to separate at that midpoint, and it's identified by soundings at a later date, and epoxy bar just defers that slab separation at the midpoint where the epoxy is sitting on the chairs, the reinforcing bar.
So this type of rebar can make a significant impact on the service life of a concrete replacement.
Exactly. Getting back to, we touched on HMA full depth repairs and offsetting the vertical joint with the base course and then 1 foot offset. The example shown in these pictures is that the paving, the installation of HMA between base course, intermediate course, and surface course should require that offsetting joint pattern as well. And this photo is just a depiction of continuous passes offset to make sure that the joints aren't stacked.
Excellent. So Tom, let's move into a fairly recent technology that we've been using quite a bit in the last 10 years, and that is Portland cement stabilization, and we have an assortment of pictures here illustrating that process. Could you share a little bit about how that process works and what are the benefits of that?
Well, Portland cement, actually, sir, started with an agricultural disc and an agricultural tractor. It's became very sophisticated in terms of the equipment that is used this day and age, and that equipment monitors the depth of the stabilization and how it's a homogeneous product that in this case was a 12-inch depth. The cubic yard weight of the existing substrate was 3,860 pounds. We used a 5% ratio, and on that basis, 5% for the 36-inch cross-section, and then multiplied by 12 to get back to 1 foot, required 64.33 pounds per square yard. And after the rotomill goes through and the stabilizer goes through, agitates the soil up, then there's a direct placement of the Portland cement powder on the grade. Typically to meet that 64 pounds per square yard, The thickness of the powder itself will be about 6 or 7 inches. There's 5 or 6 different ways to monitor the amount of and control the pounds per square yard.
Excellent, Tom. So why will a facility manager consider this technology? What are the benefits of using Portland cement silicization?
It's like a non-reinforced concrete, if you will, and it's not uncommon. In this case, at 64 pounds per square yard, 12 inches deep, it would generate 600 to 800 pound cylinder breaks. So it's a very cost-effective sub-base substrate, and if you're budget conscious and are limited to a certain degree, it is a viable alternate to reinforced concrete and 1/8 of the price.
Excellent. Excellent. So moving on, let's talk about milling. Tell us a little bit about milling in projects.
If the facility has a 500,000 square foot parking lot, let's say, and it's extremely alligatored and deflecting, rutting, displacing, there's potholes, one would look at it and say, okay, there's no value, it is way beyond its surface life, its life cycle, but there is value. The liquid asphalt that's in each and every ton of HMA is applied at about 6%. Now, a few years ago, liquid asphalts were in the $800 or $900 a liquid ton category when crude oil was going through their peak cycle and projected to go to $1,300 a ton. It didn't reach that, but they projected that. In the state rate now, it's about $490 a liquid ton. So at 6%, that's about $30 worth of recyclable material. Now, the millings are called RAP, R-A-P, recycled asphalt product. Typically, it's milled off, goes back to the plant, and the plant reuses that. What we're advocating is, folks, no matter what you do with the bidding documents and making your specifications concise, I'm suggesting that you add a line item for a per ton deductible amount for taking your asset with that value of liquid asphalt off the site and taking it back to the plant to be reused. That has a number of beneficial dynamics. Accountants really like it because it's recycled. The state and federal government will give tax deductions for recycled green issues. This is one of the issues that a lot of folks just overlook because of the condition of the pavement, and there's real significance in the liquid asphalt that's there.
Excellent, Tom. So let's move into pavement maintenance, and many of us seal our parking lots, and there's different options. There's water-based sealants, coal tar sealants, polymer, chip seal. Let's elaborate on that. What are some of the pros and cons of these types of sealants?
Sealants are an excellent, inexpensive maintenance protection that one can use for their surface asphalts. Asphalts will oxidize, they'll become more brittle, and coal tar sealers are substantially different than water-based. Water-based will not protect the existing pavement from fuel leaks, gasoline, diesel, or oil. Coal tar will, and it will defer the fuel spill to an area draining off-site. Cost, however, is about the same for water-based as it is coal tar sealers. Polymer sealers are substantially more expensive and have some different quality attributes as well. All are really good options for pavement maintenance.
Excellent. And then Tom, share a little bit about the cracks, fixing cracks with sealants as well.
The hot poured rubber crack sealer is an avenue for which to keep stormwater seepage into the substrate below the pavement itself. There is a number of different ways to accomplish that task. We advocate that it's beveled on a 45 degree at the top so that when the hot poured rubber goes into the crack, in December or January, I have seen snowplows hook onto the hot poured rubber and pull out 300, 400, 500 feet in one pass right along with it as it's connected. So a little bit of a bevel and a little bit of a finished surface on the hot poured rubber just below the surface of the pavement is beneficial.
Excellent. And then lastly, chip seal. Any last thoughts on that?
Well, chip seal applications have their place. They're used widely, commonly, and to a great extent by county road commissions on straightforward sections of county road. There's not a lot of increase in terms of any structural integrity that would be advanced as a result of chip seal, but like the hot poured rubber, it keeps moisture out from under the substrate. It is an AC application, and generally the chips are 3/8 of an inch in size, 100% crushed, and that's a protective sealant for county roads. Works real well. Becomes real difficult in a parking lot with a lot of islands and a lot of stop and goes, just for the construction train that goes along with chip seal applications, and not recommended in parking lots.
Thank you, Tom. So moving on into technical specifications of products. As we stated at the beginning, we highly recommend that you use technical specs when you're doing your projects, so that the contractors that you're inviting to bid this type of work are going to adhere to standards in the industry. And as we mentioned, the more the closer your specifications are to your local Department of Transportation, the better quality contractors are going to come to play the game or to bid this type of work. So in this particular example, we have different types of products being specified. And as you can see, these ones are referring to a state of Ohio, so we have ODOT standards. And by doing that, again, your contractors will adhere to standards for example, for aggregates, for asphalts. And when you have the project actually occurring, usually it's recommended that you have an engineer on site, confirm that these products are correct, are the proper ones, and also have a material testing company that is testing it and ensuring that the products and the temperatures and the way they're being installed are correct.
And in that case, Sergio, you need to pull extraction samples from the base course asphalt, surface course asphalt. You also need to pull cylinders on the concrete, break them at 7 days, 14 or 28 days, and take nuclear density checks to make sure that the compression on those mixes are correct and the density meets the specifications as required.
Excellent, Tom. Thank you. So let's get now into developing a program. How do you develop a program for your different parking lots? So we recommend that you first of all do a survey, a condition assessment survey. You want the conditions of those parking lots dictate the recommendations that you're going to take, and then develop estimates that are very specific to your city, your area of work, and then using that information to develop a long-range plan that you will follow for years to come. So part of the survey, the physical survey, is to do a visual, and you want to have the proper people investigating this, making sure that they're civil backgrounds, and then also to take geotechnical data from the site. So in this picture, as an example, the engineer has instructed the geotechnical company to perform 3 borings on the site on locations that they feel need attention, and we just want to understand what the soil borings, the soil composition is underneath this site. Here's an example of a geotechnical report. The advantage of having this information, it tells you what type of soils you have underneath. This is going to be key to determining what type of cross-section you're going to recommend. It may also tell you where the water table is. If the water table is too high, that's going to impact the budget and the type of cross-section or technology you're going to recommend for the parking lot.
And Sergio, the bottom line on the soil boring is what types of soil and substrate do you have, and what is their ability to carry a load?
Excellent segue. So share a little bit about the California bearing ratio.
California bearing ratio is certain substrate materials have an ability to carry a certain load, whether it's footings, foundations on a building, or a cross-section under heavy-duty truck traffic, pavement areas. Let's see, how to explain this. A fresh farmer plowed field would have a California bearing ratio of 1 to 2 in that area. Heavy clay soils will be in the 18 to 20 category. Compacted limestones will get you to the 70 or 80 with regard to bearing ratios. Asphalt pavements will move the margin to 80 or 90. Reinforced concrete will get you in the high 90s in terms of their bearing ratio and ability to handle the load. So all of that backs into cross-sectional design that addresses the volume of traffic, the axle weight or the gross weight of that volume, and what is the best cross-section with the greatest life cycle, boiling backwards to the lowest annual cost of ownership.
Excellent. Other types of information, you may have drawings for the site. You also have to take into consideration the original design criteria, as well as the current needs and future needs of the site. Perhaps the demographics on your area have changed. There's more traffic, so you have to change certain entrances or egress to the site. So taking into consideration those factors as you're putting together your plan. Again, going back to this example that we showed earlier of having an understanding of the types of loads that each one of the lots is receiving, so you can design the proper cross-section for that. Also, it's important to develop CAD drawings for the site. And then, as you've probably seen throughout the presentation, it's highly recommended that you take the site and break it down into sections, and we call them P sections. And that allows you to differentiate between concrete and asphalt and gravel areas. And it also allows you to create budgets for different sections and ultimately put together a long-term plan for the site. Other factors, as Tom mentioned, the type of volumes that are coming in, how many trucks per day are we expecting here? Look at the storm and drainage failures, trench failures, making sure you have a very good understanding of the condition of that site. And then, as I was mentioning, here's an example of the CAD drawing of the P sections, clearly delineated there. Other considerations might be any warranties that are in place, information from your occupants, the type of loads that they receive daily there. And then lastly, how do you rate the pavement? Typically, you want to take a parking lot and break it down into sections and give it a condition index. And that condition index is based on the age of the particular section, how much oxidation we have, what's the structural integrity of that particular section, how much failures do we have, and then the original design and current needs and future needs. That's part of the rating process. And what you have here on the screen is a scale or a condition index called the PCI, Pavement Condition Index. And this index allows you to rate any pavement area in the order of 0 to 100. And obviously, anything that's a fail situation is obviously a concern. Perhaps it's got a safety concern that you have to be concerned with. Anything between 50 and 30 it's more of a capital project that you have to plan for the future. And then anything above 50 is considered maintenance projects. So moving on, here's some illustrations of the survey. Obviously, you have to have the proper team to survey the site. As you're looking at the site, you're looking at the different type of traffic, the employee parking area, that's different traffic than what you have in the shipping area. And then what are the usage, like for example in this site on the back, it's more for storage. So you're probably not going to invest as much in that area. And then here's a CAD drawing delineating the type of work that's going to be performed on each location, as well as a schedule of when that work's going to be performed. And then moving on to types of deficiencies that you're looking when you're evaluating a parking lot. You're looking for cracking. Here's an example of a significant crack that perhaps it's at a point where we can't really patch it any further. Here's another example that could be patched to add more life, but again, you have to be strategic about it. Here's an example of two types, Tom,
longitudinal cracks and a transverse crack is what we're looking at right here. Substantially different than an alligatoring pattern where they may be the size of a pie plate or the top of a coffee cup. When it gets to that point, it's typically beyond its life cycle, and when the alligatoring occurs to a percentage greater than 30-35% in the parking lot, better to full removal and replacement than to try to patch it up from a cost event point of view in the long run.
So from a cracking, some cracks are due to construction, to the way the project was phased. Can you elaborate on that on this particular slide?
Well, again, we're going back to the offsetting joints from the base course to the intermediate course to the surface course, and making sure that occurs. It's also good to try to, from a logistical point of view, put together a project in a parking lot that can be completed in one day, one given area, so that you don't end up with cold joints. That isn't always possible when you're running into 300,000-400,000 square feet of parking area, but just to keep all of those contiguous joints hot. There is equipment, joint heaters and so forth, that when you're dealing with that cold joint, that should be brought to play consistent with DOT requirements as well. Proper contractor will not have a problem providing that.
Exactly. So other types of deficiencies are rutting. Here's a very good illustration of a very dramatic sample of rutting. For example, the depth of this particular deficiency is...
From the peak to the ebb of this wheel rut, it was 16 inches. We found out why it was doing that by virtue of some soil borings. This is well over a 100-acre site. When it first started, the access point was on the east end, and as the site grew, they decided to relocate the main entrance in the middle, and it just happened to be over where they buried the stumps 20 years ago, and there was a pocket of organic below this entrance area that was 15, 18 feet in thickness, and as it was going away, it was taking the pavement around. So again, soil borings help to eliminate this kind of a problem from wheel rutting.
Excellent. Another type of rutting that's basically from wheels, from the wear and tear of parking cars in a particular area. Then, of course, many of us are familiar with alligatoring. Alligatoring essentially is when your pavement has lost pretty much its structural integrity. And when you see this level of alligatoring, you essentially are at the end of the life of this parking lot. So there's no point on sealants or performing any repairs. You really are ready for a full replacement project. So alligatoring is probably the one that's most common, and those things can be itemized in your survey so that you can develop a plan of attack for those areas.
And keep in mind, when you mill off that product and generate a outbound recycled asphalt, it has value.
Thank you. And then obviously concrete, you may have some concrete assets as well, and the typical problems with concrete is falling, and that happens from oxidation sometimes of the rebar, from the rust that's pushing it out, or just impact. In this case, for example, it's from a dumpster impact that has significantly affected the integrity of this loading dock. So this is sort of an assortment of the different types. We didn't get into any type of trenches, failures, but that's another aspect in your process of surveying the site. So taking into consideration all these conditions, what you do is now you let those conditions dictate the recommendations, and then to complement your corporate objectives. And I want to highlight the corporate objectives because perhaps your company or your organization has decided to not invest any further in that particular site. So you may take a different approach even though the parking lot requires a full replacement. But essentially, you typically fall into either maintenance dollars, repair, perhaps there's some restoration processes, or a full replacement of the parking lot. You take this information, you analyze it, you look at the different cross sections that are available for the current need of the site and the future need of the site, and then you put together a budget. You do a life cycle cost analysis. And the illustration that we have here on the screen is essentially a comparison of a 10-year cross section that will cost you $100,000. Therefore, your annual cost of ownership is 10. Or you can do a 15-year cross section that will last you 15 years, and therefore the annual cost of ownership is $8,300. So the point of this illustration is take that into consideration, not just the low cost of the project.
And Sergio, the other extreme is the public utility, $300,000 plus, lasted 3 years. That vaults life cycle cost annually to in excess of $100,000 a year. And it's just lack of proper design for traffic volume and axle weights.
Great point. So bottom line is budget estimates. You want to have make sure that the costs are tied in with the specific state and region that you're in. That way your plan is tied into actual numbers. So your estimates are really critical. As many of us know, you don't have a good budget, you can lose a lot of face when you're requesting funding. So as we begin to wrap this up, basics of developing a program, you want to make sure you collect information from a good survey. You put this information into a pavement program. And then obviously you can integrate this with other systems that you have. Obviously you have roof systems, you have mechanical systems, you have parking structures, and perhaps envelope systems. So this is just obviously one part of your entire facility's asset. So to wrap it up, we just want to show you a quick sample. This is a site that was a survey. It's got about 27 pavement areas, and all the delineations that you see there are broken down by year of work. And then this is the sheets, the data that's collected for each site. We're looking at information pertaining to the pavement surface, the curb and gutter conditions, the drainage conditions, all the markings, the signage,
the amount of cracking, the amount of alligatoring, the integrity of the storm inlet structures, frost heave that it might have created a safety trip hazard with concrete walkway. Pretty in-depth, thorough analogy of your infrastructure system with regard to paving, parking, and walkways.
Exactly. So each pavement area, the first one we showed was pavement section number 1. This is pavement section number 2. And each one is giving a PCI scoring, and that we'll show you in a minute. And then the analysis obviously will include images illustrating the different conditions that were found throughout the survey, illustrating not only the top or the information that's visually seen, but also looking at the trenches and the drains, so that all the conditions are inventoried as part of a comprehensive report, including the condition of the markings, the signage of the site, any concrete deficiencies. And then lastly, this is the PCI that we use, which is basically a standard. This was developed by the University of Wisconsin, and it's an actual system that's called PACER, P-A-C-E-R. So if you go across the country, just about every civil engineer will use this particular grading scale to score each one of the pavement areas.
So whether you're in California, Texas, or Ohio, when you refer to a pavement condition HMA and it's a 30 or a 50, everybody knows if you follow the PACER manual what conditions that represents.
Excellent. And this is a summary of the condition index for this particular site, rating it from good, fair, and excellent shape. It's a scorecard. It's a complete inventory of the asphalt, gravel, and concrete that your site has. And then finally, this is the budget that you will develop for a long-range plan, where you can see a schedule for the next 10 years that's spread out, where you have 2.7 to 3.1 million US dollars for the work. So in conclusion, the benefits of developing such a program: it helps you prioritize and develop a budget, and allows you to forecast future projects. And then because you have illustrations, you can use it for presentations to management when you're requesting funding. It's a good tool for record keeping as you're improving certain parking lots, certain pavement areas. You can record keep the ones that you're improving as you go along. And then that information is also good for project management. Since you invested on the survey, you can take that information and transfer it to the project management team so they can execute the work. And as I mentioned earlier, you can share this information with the rest of your team. So, well, that comes to the conclusion of our presentation. We have a few questions that came up. And Tom, I see one of the questions by one of the individuals there. They're asking, Tom, how often should you apply sealants to parking lots?
Varies a little bit, Sergio, in that the parking areas where the automobile actually sets has a life duration that generally encroaches that 4 to 5 years. The access roadways to those parking areas seldom makes it 3. So it's a blending of the program. That said, if you pick 3 to 4 years in terms of a seal coat maintenance program, you're probably in the proper ballpark.
Excellent. And then another question, Tom, would you recommend concrete or asphalt for a new trucking lane?
Typically, it's reinforced concrete just for the sheer volume and the gross vehicle weight, axle load. It is the Cadillac side of the cross-section, costs a little more. As a rule, one may also entertain an alternate that would include Portland cement stabilization with an HMA overlay to get to that bearing ratio that will give you the life cycle over time to ensure the lowest annual cost of ownership.
Excellent. Another question, do we have any experience with BioSeal pavement rejuvenators?
There's reclamites on the market, okay, which help improve the flexibility of the placidity of the oxidized surface course. A lot of them are yet unproven or lack that 10-year track record. There's a number of studies that are coming out on plasticizers and rejuvenators, and we're still deep into it. We just, I'm a little reluctant to spec it until they have that proven track record.
Thank you, Tom. And then another question here, what is a better option, wire mesh or fiber mesh?
I'm an advocate of wire mesh, and I've been into a lot of different studies that fiber mesh adds to the spalling, surface spalling. I guess school's still out on that, Sergio.
Okay. Well, thanks everybody. Last question is the slides printable? Absolutely. We will send you a link where you can print these slides. Thank you everybody, and good luck, and good luck with your projects this year.